Hi, I'm Myung Ye from Group X. My matching number is A24KE0377. And in this video, I will talk about the three steps of the circuit in our assignment 1. So in this one is the step 1. So let's talk about the circuit. This one is the step 1, the full wave bridge rectifier circuit. And this 4 diode will show the function of the full wave bridge rectifier. As we can see, this one is our function generator. We have 5 Hz of frequency and also 10 volt of amplitude and a DC offset of 2.5. So at here, we will perform a graph, sine graph like the upper one and lower, upper, lower, upper, lower. And in this form, we will produce a positive part and also the negative part. So we can see it here. Yeah, this is the result of the oscilloscope, almost the 5 volts. So that's all from our group. Thank you. So at here, we can see the flow of current. It comes from the positive one and it won't pass through the D1 because D1 is act like the reverse diode. So the current won't flow through it. So the current flow through the D2 because it is a forward diode. And then the current won't pass through the D4 because it's also a reverse diode. So the current will flow like this. So the current will pass through the R1, the 1 kilo ohm of resistor. And then current will pass through the D3 because it's act like the forward diode. And then finally go to the negative part. So at our circuit, we connect a multimeter with the R1 and also an oscilloscope to the R1. And we want to see the waveform of the R1 and also the VDC of the R1. So after we run the circuit, we have a result like this. So at here, we can see the waveform of the voltage is like the one higher and also one lower, one higher, one lower. So why the waveform will see like this? Because there's a 2.5 volt of the DC offset. In the normal one, after the AC voltage is passed through the full wave rectifier, we will produce like a 10 volt, 10 volt, 10 volt because our amplitude is 10, right? So, but in this case, we have a 2.5 volt of DC offset. So it will produce like, you can see it here. The higher point is almost 11.742. So at here we can see that the amplitude is 10, right? So it will plus another 2.5 because it's a DC offset here. So it will become 12.5. But in this case, we have passed through two diodes, the diode, the D2 and also the D3. So like in this case, the full wave bridge rectifier is it will transfer the AC voltage. Like in the AC voltage, it have positive part and also negative part, right? So after pass through the full wave rectifier, it will produce in one direction only. So all in positive. So at here we can see the higher one is the 11.7.742 and the lower one is almost 6.756. So because number one is 10, right? 10, 10. So in this case, the tens will plus 2.5 and minus 2 times the 0.7 because one diode will minus a 0.7 voltage here. So two plus together will have almost 1.4 volt. So at here you also have the 6.756 because at here it will have a 7.5 because the negative 10 will plus 2.5 also because it's a DC offset there. So it becomes 7.5, negative 7.5, and then it will reflect to the positive part. So we can't 7.5 at here, but we need to minus 1.4. Yeah, so almost the 6 point more volt. So that's why we can find out there's a waveform at here for the step 1 circuit. So this multimeter at here show a result of this one. This one is the VDC of the voltage that will pass through the R1. So at here is it's also called the voltage average. Yeah. So next move on, we need to see the step 2. Step 2 is the full wave bridge rectifier with a filter. Yeah, the capacitor is act as a filter, but in the assignment, it will have a value of 10 by 10 UF. Yeah, so this one is the question provided. So let's see. Because the capacitor is act as a filter, yeah, it will smooth the voltage flow. Yeah, it will smooth the DC voltage flow. So at here, it will produce a result like this one. But in this case, it's not too smooth, right? Because the value of capacitor is very small. So our group member decided to change the value. Yeah, we make it become 100. And then when the value of capacitor become higher, yeah, it will produce more smooth of the voltage. Yeah, so we can compare. In step 1, we have this form all in positive sign. So in step 2, we will filter, yeah, we will smooth the voltage. by using a filter. Yeah, there is a capacitor. So there's the difference of the step one and also step two circuit. So the other one is almost the same one. Like there's a function generator with its value 50 hertz frequency, 10 amplitude, and also DC offset of 2.5 volt, and also a full F bridge rectifier at here. But the only difference is there's a capacitor here. So the capacitor will help to filter the voltage, yeah, produce the voltage in a more smooth form. So as we can see, the VDC have changed. Yeah, this one is almost 6 volt, right? So this one is 10.86 volt. So this is because the VDC also as the V range. Yeah, so at here the V range is all at the more higher point, like 10 volt, 11 volt. You can see at here, channel B. Yeah. So it produce a VDC like almost 11 volt. So after this, we need to produce a DC voltage. Yeah. So at the step three, it requires us to perform a full wave bridge rectifier with a voltage regulator. So so here our group decided to put a higher capacitor, high value of capacitor here, and also put a resistor as a R2 at here, and also a Zener diode at here. Yeah, we add these three into the step one, into the step one circuit. It will look like this. So what's the function of C1? It is used to filter the voltage, make it more smooth like the step two. So after smooth the voltage, so we need to produce the DC voltage, right? So we put a resistor at here, and the function of this resistor is used to limit the current flow through the Zener diode. Yeah. And here we put a Zener diode in this direction because we need to have a reverse one. Yeah. So we need the current pass through the reverse Zener diode. The difference of Zener diode and the normal diode is the Zener diode can pass in the reverse form. So here we put a 5 volt here, so it will parallel to the R1. So at the end, it will produce almost a 5 volt of the DC voltage at here. Yeah, this is our result. So why it will look like this? Because the current flow through it is higher than the 5 volt, right? We see it here almost 10. So the current can pass through it because the voltage is higher than the Zener diode one. So here the current can pass through it, so it produces the same voltage at the R1 as the Zener diode. So this one resistor limit the current flow through it to prevent the Zener become damaged, and then the current also can flow through it from the positive part. It will pass through the D2, then pass through capacitor filter it, and also pass through the Zener diode. So this one. So the R1 is parallel to the D5, so it will produce almost same voltage. So at the end, there's a complete circuit.